In this video, we'll once again look at circles in the coordinate plane. But this time we're going to be using some algebra in order to do what I'm going to call completing the square. Remember that in order to be able to graph a circle, we need to know the location of its center and the length of its radius. In the previous video, we looked at equations of circles written in center-radius form. And we said the equation of a circle that has its center at the point hk and a radius of length r is going to be expressed by doing x minus h the whole quantity squared plus y minus k the whole quantity squared equals the length of its radius squared. But what happens when our equation isn't in this form? How can we then manipulate it to be in this form so that we can determine the center and the radius? That's what this video is all about. For instance, if you look at number 1, we're given the equation of a circle, but it's not in the form where we can easily determine the center and the radius. We're going to manipulate it into that form, and here's how. The process seems a little bit lengthy at first, but once you get used to it, it really isn't in fact all that difficult. I'm going to begin by grouping every single term that has an x in it together. So I'm going to rewrite this such that the x squared and minus 10x are together. Then I'm going to group the terms with a y in them together. So plus the y squared, subtract the 2y. And then any term that doesn't have an x or a y, I'm going to add or subtract to move it to the other side of the equation. So in this case, I would subtract the 10 from both sides of the equation so that that constant term, the term without the x or the y, is on the right side of the equation. In the next step, I'm going to do what I'm calling completing the square. So I'm going to, at this point, make the x squared minus 10x into a perfect square trinomial so that I can then factor it using each equal factors. I'm going to do that by adding some random number, well, not really random, but some number to both sides of the equation. So I'm going to leave a little blank there to indicate that I'm going to complete the square and add some number to both sides. And likewise, I'm going to do the same thing for the y's. Y squared minus 2y plus some number to complete the square is going to be equal to negative 10, but I have to remember that I added some number to the left side of the equation. In order to maintain the balance, I have to add the same number to the right side. And for the y terms, I'm adding that number to the left side. I also need to add it to the right. And at this point now, I'm going to do what I call complete the square. This process is going to seem a little bit long at first, but once you do it a few times, you'll become a natural at it, and it'll progress a lot more quickly and efficiently. I'm going to say to remember that when you go to factor, in order to get an x squared in this first box, the only way you can do that is by having an x and an x. And if we're going to make this into squares, which is what we're really wanting to do because we're completing the square, I know that in order to be even, each one of these numbers here is going to have to be a 5. I'm going to make them negative because I want them to add up to the negative 10x. So now when I go to multiply x times negative 5, that gives me negative 5x, x times negative 5, negative 5x. But the number I'm really looking for here is the negative 5 times the negative 5, or the positive 25. That's the number that I'm going to use to complete the square. And again, this seems kind of long at first. By the time you practice it a little bit and get used to it, it'll become more natural feeling, and it'll progress much more quickly than it does at first. For the y values too, I'm going to come and I'm going to do or complete this square. So I'm going to start with a y squared here. So the way that we get y squared is by doing y times y. We want to have a minus 2y altogether. So again, if I think about having a square, I'm going to need minus 1 of those on each side so that they're the same size. Minus 1 times y is minus 1y. Y times minus 1 is minus 1y. But the number that I'm really going for is this number that is used to complete the square, the minus 1 times the minus 1, or the positive 1. And again, I'm going to add that to both sides. The way I've set this up now is pretty nice because you can read the factors x minus 5 times x minus 5, or in other words, x minus 5 the whole quantity squared. For the y values, I've got y minus 1 times y minus 1, or y minus 1 the whole quantity squared. And on the right side of my equation, I'm going to combine the negative 10, the 25, and the 1 to get 16. So now I've put my equation in center radius form. I can see very clearly now that the center of this circle is going to be at the point whose coordinates are 5, 1, and the length of the radius of this circle is going to have to be the square root of 16, or 4. All right, so that process feels slightly overwhelming, very long in the beginning, but again, the more we practice it, the better we're going to become at it. I'm going to go ahead now and jump right into the next one. Number 2, again, we're given an equation of a circle, and we want to put it in center radius form so that we can determine the location of the center and the length of the radius. Once again, I'm going to begin by grouping all my x terms together. And this time I'm going to keep in the back of my mind that I am going to want to complete that square, so I'm going to start out by leaving a little blank there. Then I'm going to group all the y terms together, keeping in mind that I'm going to want to complete that square. I'm going to subtract the 4 from both sides, remembering to add the values that I get when I complete the square for the x's and complete the square for the y's. At this point now, I'm going to go ahead and complete my square. So these have to be an x and an x. That minus 4 tells me that this number has to be a subtract 2 and a subtract 2, making the number that I get when I complete the square plus 4. Now if I wanted to, I could write my minus 2x and my minus 2x, but really this number I'm going for here is that 4 that I need in order to complete the square. When I go over here to repeat the process for the y's, I've got a y squared, so again a y times a y. This time I want a plus 6y, so I need half for the top, half for the left, making the number that I get when I complete the square the plus 3 times the plus 3, or the plus 9. And then I'm going to add to both sides. And now I can very easily and efficiently read my factors here. I've got x minus 2 times x minus 2, or x minus 2 quantity squared. For the y's, I've got y plus 3 times y plus 3, or y plus 3 quantity squared, equals, when I combine all the terms on the right side, a 9. So the coordinates of my center now are going to be 2, negative 3, and the length of my radius is going to be 3. All right, this process is starting to feel a little bit quicker and a little bit better, but hopefully just to make sure that things are cemented in your brain, we're going to take a look at one more here together. Now unfortunately, when we put these notes together, I didn't notice that this was a repeat of the first example. So if it hasn't been already, I'm going to go ahead and I'm going to change this to make this x squared subtract 8x plus y squared subtract 2y subtract 8 equals 0. We want to do something different, not something that we've already done. But the process is still exactly the same. I'm going to group my x terms together, leaving room to complete the square. Group the y terms together, leaving room to complete the square. And move anybody that doesn't have an x or a y attached to it over to the other side simply by adding or subtracting. And again, recalling that I have to add the number that I used to complete the square for the x's and the number that I used to complete the square for the y's to both sides of my equation. My next step is to go ahead and complete that square. So I've got my x squared with my x times my x. In order to get minus 8x in the middle, I've got to have a minus 4 and a minus 4. And that number I'm really looking for, the minus 4 times the minus 4, or the positive 16. That's the number I'm going to use to complete the square for the x's. Moving along to complete the square for the y's now. Again, I'm going to get that y squared by doing y times y. The minus 2y in the middle has to be split up evenly amongst the top and the left side, so minus 1 for each, making the number that I get when I complete the square there a minus 1 times a minus 1, or a plus 1. My factors I can now read fairly easily from my little table. It's x minus 4 times x minus 4, or x minus 4 quantity squared. The y value is y minus 1 times y minus 1, or y minus 1 quantity squared, equals 25. And now that I've put my equation in center radius form, I can read pretty quickly from this that the location of its center is at the point with coordinates 4, 1, and the length of its radius is equal to 5. As always, I want to thank you for the gift of your time in watching the videos and ask you to take a few minutes, think about, reflect upon what you've seen and listened to, write down the key ideas and the important takeaways that you need to know from this video, and then see if you were able to use and apply what you've learned in order to tackle those questions on the next page. Of course, if you have questions about what you've seen, please feel free to pause and rewind and replay the video, or write them down so that I can address them the next time that you come back to class.